research project is how we are improving lubrication in the pulp and paper industry by collecting data and trying to reduce downtime, specifically for the manual lubrication process. So I'm a master's student from University of Waterloo, and my other partner here is Nathan, who is a computer science student from University of Waterloo. So why this topic? So I used to work as a reliability engineer for a Fortune 500 pulp and paper company in Tennessee. I was helping mainly with the converting side, but also on the paper mill side. And I was over putting together a preventative maintenance process together for this company. And even though what I saw was, even though lubrication was such a basic but a critical task, it seemed like there was a lot of human error in this process. It was, the process wasn't working together very well. And I constantly had issues with the process, so when I started with my master's at Waterloo, I figured I should be looking into this problem that I had. So the first question is lubrication important? Many journals that I've come across say that lubrication is the #1 reason equipment fail prematurely in manufacturing in general. And about $240 billion is lost in productivity due to improper lubrication, just in the US every year. And 50% of all bearing failures is due to improper lubrication. And this is a case study done by SKF and TAPI, specifically in the pulp and paper industry. It breaks down all the reasons for bearing failure. And it shows that 54% of all bearing failures is due to improper lubrications in the pulp and paper industry. And given that every minute for paper machine is $20,000 worth of productivity, and also there's a case which shows that in North America, about 2 million is lost for a specific paper mill due to improper lubrication every year. So all these reasons were the convincing argument as to why this is an important problem to pursue. Why do bearings fail? One of the many reasons is improper lubrication. So if bearings are under-lubricated, the metal elements of the bearings rub against each other, causing friction and heat and vibrations, causing the bearings to fail. This is a picture of an extreme situation where obviously the heat and vibration melted the bearing due to not enough lubrication, and the bearing failed here. And in this scenario, the other problem is over-lubrication. So if you over-lubricate bearings, they fail, and thus because the chemical elements of the lubricant itself is compressed to such a high pressure that they solidify and prevent the right amount of lubrication from going into the right elements of the bearings. The goal would be to prevent bearing metal elements from rubbing against each other. So when they solidify, they prevent new lubricant from reaching these elements, and hence causes friction and reduces the life of the bearing. The other problem due to over-lubrication is there's too much pressure, breaking the seal of the bearing, opening up the bearing to external elements, which causes contaminants to go in, which also reduces the lifetime of the bearing. So that leads to the next issue why bearings fail, which is contaminants. There's 4 kinds of contaminants and issues caused by these contaminants that fail that mainly cause bearings to fail. One is erosive, where particles get into the bearing lubricant, and the particles in the process of bearing rotating, particles hit against the surface of the bearing, dent the bearing. That is the far right side picture that's shown. The other is adhesive, where the lubrication viscosity itself is the problem. It doesn't prevent the metal of the bearings from touching each other. As a result, there's a momentary welding created, which again momentarily later shears, causing all kinds of dents within the bearing and friction, and reduces the life of the bearing. The other form of issue is fatigue, which is the far right lower picture, and that's extension of erosive lubrication failure, where the particles collide between the 2 metal parts of the bearing and causes cracks, and these cracks eventually causes a fatigue within the bearing. And perhaps the most common form of bearing contamination failure in pulp and paper industry is corrosive, where the water gets into the bearing because it's not either sealed properly or due to other reasons, and causes corrosion inside of the bearing, which is mostly rust. The other main reason why bearings fail is the process itself. If the bearings are not consistently maintained, tracked, and etc., and not lubricated at the right frequency, right type of lubricant, right amount, this reduces the life of the bearing. So why does traditional manual lubrication process fails? So this is what a traditional manual lubrication process looks like. A person would walk around with a lubrication gun within a mill and lubricate all the bearings in the mill. And as you can see, bearings are sealed unless it's over lubricated, and usually inside the housing of the equipment, and it's hard to tell if they are being properly lubricated or not. And the common problem is human error, where they over lubricate or under lubricate bearing. There's a picture of over lubricated bearing. It's pretty common to see across paper mills. And this is a picture from the converting side. There's a corrugator inside a converting facility, and paper machines are much bigger than this. And there are these many bearings in a corrugator located everywhere. So it's obviously it's pretty tricky to track these bearings. So poor tracking is another issue. There's either paper logs or there's some kind of technological solution where there's an iPad to try and track all these bearings. But due to the nature of the problem, it's hard to track these bearings. And there's time constraints. Production is always trying to keep the plant running, but maintenance sometimes needs downtime to take care of the equipment. So as a result, there's time constraints, and you can't get to all the bearings in the given time. As a result, a bunch of bearings are missed. And if they're not tracked properly, they keep getting missed and eventually fail. And the other thing is the process. There's 5,000 bearings in a mill, and the process could be paper-based or could be some kind of tech where there's iPad communicating to the CMMS software. And if the process is not good, if all of these bearings are not being tracked, eventually that's the biggest reason manual lubrication doesn't perform well. There's another reason is skill gap. This is a recent phenomenon after COVID where, especially in the US, there's a shortage of skilled maintenance technicians, and more the newest person does the maintenance job when it comes to lubrication. Existing solutions. So maintenance management system is the most common way to try and solve this issue. So this is a software system that keeps track of sections of the equipment and keeps track of the lubrication frequency for all these bearings that are in the plant. But the issue is they're not granular enough. So it would say something like, hey, you're lubricating this section of the equipment, and that section could have hundreds of bearings. As a result, it is easy to miss many bearings within the process, and the feedback loop for the maintenance management systems is very human. So it creates a room for human error where it's either paper-based or someone sitting at a computer and saying, yes, I did all this tasks that's assigned to me in the work order. The other form of solving this issue is automated lubrication systems. There are many, so these are equipment that automatically pump grease to bearings at a certain frequency and certain pressure, certain type, etc. But the biggest reason, after doing hundreds of interviews, what we found is they are really only on 40% of the bearings within paper mills, mainly because of the cost consideration. It doesn't make economic sense to put it on all the bearings. Sometimes equipment is not suitable, either there's not enough room or the type of if the equipment moves in and out, it's not suitable to have automated lubrication system on. It's still prone to human error in terms of people can put in the wrong type of lubricant within the automated lubrication system. And this another surprising reason what we found from our interviews is that maintenance managers prefer humans to walk around bearings while lubricating it, so they can they sort of act as sensors and watch how the rest of the equipment is working. So this is another critical human feedback on how the equipment is working properly. So our solution, we came up with the solution after coming up with many proposed solutions, and the main things we wanted to do was we wanted to track the lubrication process automatically. We wanted to prevent lubrication mismatch, putting in the wrong type of lubricant, or putting in the wrong amount. Now is the time for the video. Now is the time for the video. Sorry. That's good. Thanks.
Want to stop it?
Yes, yes. So the next step of our project is we are working with some industry partners. We're collecting data on if you're trying to solve these three main issues. We come across manual lubrication to see how effective the solution is, or if it's the best solution to do it. And we are also looking for more industry partners to do case studies and collect more data. Yeah. Last slide. Thanks.
Yeah, thanks for the interesting presentation. Oops, sorry. Any questions from audience members? Maybe I have one. We'll check the online audience as well, but I'm just wondering how, so these maintenance practices have been developed over time and sort of formed a set of best practices. So what you're doing, it looks like, is tracking that, which is probably a great improvement. I'm wondering what kind of data you might be able to collect to sort of understand whether these are the good or the best practices, or if there's some way to kind of improve on the heuristic methods that have been developed over decades of operating the machine.
Yeah, the biggest things through interviews that we found was they wanted to prevent missed points. So we'll be tracking if bearings are getting lubricated or not. And one is, the other thing is if they're getting over lubricated or not, or under lubricated, or missed or wrong type of lubricant. And if they're being lubricated at the right frequency as planned through a maintenance management system.
Do you tag all of the nibbles that you're doing? How do you?
Yeah, we put RFID tags on all the nibbles.
And how do you determine how much grease do you need to research that particular bearing to see the quantity of grease that has to go into it?
Yeah, so usually the mills already have that information. It's just that it's hard to track because of human error if they're putting in the right amount. So we have that information through the mills, and then we are verifying that they're actually we are giving them feedback saying, yes, this is the amount you need to put, and we're verifying that they're putting that amount.
So your device tracks the amount, it actually has some sort of an indicator to say how many mils or whatever grease was in?
Yeah, so what we do is with electrical grease guns, we want to put a flow meter in eventually.